Hello everyone, this is Gitsi, and in this video we are going to construct LL1 past table, I mean predictive past table for the grammar, right? So in order to construct this past table, we should know what is the LL1 grammar, right? So here the first L stands for scanning the input from left to right, right? The second L stands for we are going to use leftmost derivation, and this one stands for number of symbols you can look ahead while taking decisions for the parsing, right? So this is the LL of one parse table, and for this construction we need to follow a few steps. So in this video we are going to go through a few steps, and in the subsequent videos we will continue with this, right? So let us see with an example. In here, this is the given grammar, right? So it consists of nearly 6 productions. So for this grammar, we need to construct LL1 past table, I mean predictive past table. So these are the few steps we need to follow. The first thing is we have to analyze the given grammar, and we need to check whether any left recursive production occurs in this grammar. So in this video we are going to see what is left recursion and how can we eliminate those left recursion, right? This is the first thing we are going to see in this video, and in the subsequent videos we will be determining the first follow functions and the past table construction, right? So let us see this left recursion. So in the grammar, a production is said to be left recursive if and only if, see here, the leftmost symbol, right? Let us see. So the leftmost symbol of the production body, that is body of the production, the same as the head of the production. Then this production is said to be left recursive and the grammar is left recursive grammar. See, I repeat once again. See, the leftmost symbol of the RHS, I mean the body of the production, is same as the head of the production. So if it is so, then this production is said to be left recursive production and the grammar is said to be left recursive grammar. So here E is the leftmost symbol of the production, that is body of the production. It is same as the head of the production, right? So how can we eliminate this left recursion? Let us see in this video. Let us take, if there is a production A implies A alpha and A implies beta, right? So if there is a production like this in your grammar, then this is it will be left recursive because here A, that is the leftmost symbol of the body of the production is A, which is same as the head of the production. This is it to be left recursive. So how can we eliminate this left recursion? Let us take. So here what we are going to do first is we have to introduce a new non-terminal. Let us take A dash, right? So I can rewrite it as A generates, right, beta A dash. See, keep it in mind, alpha is nothing but some set of terminals and non-terminals. Similarly, beta is also some set of terminals and non-terminals, but beta doesn't start with E. Right? Let us assume beta doesn't start with E. So here we can introduce a new non-terminal A dash and we can write it as A produces beta A dash and right, and A dash generates, right, alpha A dash or epsilon. So for this, this is what we have to write, right? So A generates A alpha or beta. For these two productions, we can rewrite these two productions as A generates beta A dash and A dash generates alpha A dash or epsilon. Right? So this is the rule for eliminating left recursion. See the rules, see the terminal, this production. Here there is no left recursion because beta, here it is A. See, we have assumed that beta doesn't start with A. So beta is not equal to A. And here alpha and this also A dash. So alpha is some set of terminals and non-terminals. This also doesn't start with A. So A dash generates alpha A dash. It doesn't contain any left recursion. And A dash implies epsilon, there is no left recursion. So in the resultant production, we don't have any left recursion. So we have eliminated all the left recursions. This is the rule. This is how we have to eliminate the left recursion. So let us analyze our grammar. Here, first, let us see the first production. E generates E plus T. So here the leftmost symbol of the body of production is E, and this is same as the head of the production. So this is left recursive production. Right? So the first production is said to be left recursive. And second one, here it is T, here it is E. It is not equal, so this is not a left recursive production. And here let us see, so the first, that is leftmost symbol is E. Right? This is same as the head of the production. So this grammar is said to be left recursive grammar. Right? And the next one T generates F. So here F is not equal to T. So this is not left recursive production. And see this production, F generates open bracket E close bracket. So leftmost symbol is open bracket and here it is F. This is not equal, so this is not left recursive production. And this is also not a left recursive production. So in the given grammar, there are two left recursive productions. So we have to rewrite these left recursive productions as we have seen in the previous slide, right? So how can we eliminate? So the first, let us see, E, let's take E generates E plus T, and for E, one more production is there, T, right? So we have seen that A generates A alpha or beta. This then be rewritten as A generates, right, beta A dash, and A dash generates alpha A dash or epsilon. Right? Similarly, for this production, so what is alpha here? Plus T is nothing but alpha and T is nothing but beta. So we can rewrite this as E generates beta, right? Beta is nothing but T. So T, we introduce a new non-terminal, let us take E dash. Now, E dash generates, right, alpha A dash. What is alpha here? Plus T, E dash or epsilon. Right? So these two productions can be rewritten as these three productions. E generates E plus T or T. So here, see this resultant productions. See here T, E. This is not equal. So this is not a left recursive production. And here plus this is F dash. So this is also not a left recursive production. And here epsilon and here is F dash. This is also not a left recursive production. Right? And let us see. So the first one is over, right? First thing is over. And let's see the third one. This is the left recursive grammar. Because the leftmost symbol in the head of the body of the production is same as the head of the production. This is the left recursive grammar. As we know the rule, let us take A implies A alpha or beta. If you have such a production, then it will be A implies beta A dash and A dash implies alpha A dash or epsilon. And here our production is P implies T star F, right? And here for T one more production is there, F. See, T implies T star F, and for T one more production, F, right? So this is alpha and this is beta, right? Now it can be rewritten as T implies beta T dash. What is beta here? F. So F T dash, right? And T dash implies alpha A dash. What is alpha here? Star F. And what is A dash? That is T dash or epsilon. So instead of this production, we will be writing these three productions. T generates F T star T dash and T dash generates star F T dash or epsilon. Right? So the resultant grammar will be, this is what your resultant grammar, right? So instead of E implies E plus T, right? We have written this. Let us E written T or T. For this, we have written these two. And for T is T star F. Instead of this, we have written as T or F. But instead of these two protections, we have written these three protections. Alright. So this is your resultant grammar after eliminating the left recursive protections. Right. So this is how we can eliminate the left recursions. I'll repeat the rule. So the rule here is, if your grammar contains a protection like this, A generates A alpha or beta, then you can rewrite these two protections as, let us write here, A implies beta A dash and A dash implies alpha A dash or epsilon. Right? These are the rules we have to follow for eliminating the left recursive protections. So this is what the resultant grammar we got after eliminating the left recursive protections. Right? And in the subsequent videos, we will be seeing the determination of first and follow functions and how can we construct or how can we fill the parse table using this first and follow sets. Right? Thank you.